This is AP Calculus. This is lesson 3.3, and in this section we're going to talk about differentiating inverse functions. And the first thing I'm going to do is review with you what inverse functions are in this section. When you were in Algebra 1, your first introduction to a function should have been, your teacher probably introduced you to a relation, which is a set of ordered pairs, and the relation, remember, is a function if none of the x values repeat, meaning it will not fail the vertical line test. If you graph all the points and a vertical line only hits 1 point, and there are no vertical lines that will hit more than 1 point, then you know you have a function. An inverse function is simply when you switch the x and the y values of your ordered pairs or of your relation. So the inverse function of this one that I have listed here would be 4, 2, 6, 3, 5, 8, negative 2, 1, negative 3, negative 1, and 2, negative 5. That is a function because none of my x values repeat. So the relation was a function, the inverse relation is also a function, and the inverse, remember, is when we switch the x and the y values in our ordered pairs. The next thing you probably learned about inverses is you probably learned how to take the inverse of the actual function written as an f of x, written as function. And in order to do this, the first thing you have to do is realize that f of x is the same thing as y. You would replace f of x with y. Then you would switch the x and the y. If the inverse function of a relation is what you get when you switch the ordered pairs, that same thing holds true when you switch the x and y value in the equation for a function. So if I swap the x and y value, I would have x equals 3y plus 2, and then to write that as the inverse function, I'm going to solve for y. So I'm going to move the 2 over, then divide by 3. That gives me y, and this would be the inverse function of the function I started with. So I would write that as f negative 1 of x. This is the notation for the inverse of f of x. And that function would be 1/3 x minus 2/3. So that's probably the easiest way to find the inverse function if you're asked to find the inverse. And sometimes when you're dealing with calculus, they will give you one function. You'll have to know what the other function is in order to be able to find the derivative. Because you'll have to find some ordered pairs and things like that sometimes. It just depends on what they're asking you to do as to what you'll have to do. So all of this information is useful in dealing with the calculus. After you dealt with inverse functions in Algebra 2, you probably dealt with inverse functions again in pre-calculus. And usually in pre-calculus, this is where this idea of an inverse function is introduced. Two functions, f of x and g of x, are inverses if and only if the f of g of x, the composite function, when you plug the g function into the f function, gives you x. And when you plug the f function into the g function, you get x. So two functions are inverses if their composite functions are equal to x. And so I'm going to use those two inverse functions that we talked about in the last segment and see if they're inverses by using composite functions. So in that first example, when we found f of x, or we were given f of x equals 3x plus 2, and then we found its inverse function to be 1/3 x minus 2/3, instead of naming this one f of negative 1 of x, I'm going to name it g of x, so that it matches the notation that we have here in the definition. And if these two are inverses, then when we do the composite function, when we put g into f, we should get x. And when we plug f into g, we should also get x. And as long as one of those, one or the other works, you know they're inverse functions. You don't have to do it both ways. So if I find f of g of x, I'm going to take the f function, and everywhere there's an x, I'm going to plug the g function in for it. So that would be 3 times 1/3 x minus 2/3 plus 2. So if I just do the math real quick, I've got x minus 2 plus 2, which does give me x. So f of g of x is x. I could do it the other way as well. I could find g of f of x. In this function, I'm going to take the g function, and everywhere I have an x in the g function, I'm going to plug the f of x function in. So everywhere here there's an x, I'm going to plug this x in for it, or this f of x in for it. So if I do that, I have 1/3 times 3x plus 2 minus 2/3. And this is finding g of f of x. So if I distribute, I have x plus 2/3 minus 2/3. That does equal x, showing me that they are inverse functions. It's also important to understand how graphs of inverse functions relate to each other. Remember, if the ordered pairs have been switched, the x's become the y's and the y's become the x's, then the graph, it's going to do something different to the graphs as well. What you're going to have is this function is going to flip across the y equals x line, or f of x equals x line. And we'll look at how this works. This ordered pair is 0, 1. So if I switch that, it's going to be the ordered pair 1, 0 for the inverse function. This ordered pair was 1, 2. So if I switch that, I would have 2, 1. This ordered pair was 4, 3. If I switch that, I'll have 3, 4. This ordered pair was 9, 4. So if I switch that, I'll have 4, 9. And if I look at that graph of the inverse function, you can see how this function is flipping across the y equals x line. And that will always happen with an inverse function. If you have a straight line, it would flip across that y equals x line. That's always going to be the case. It will be symmetrical about the y equals x line.